All right. So when will it reach 150,000 people? Since it's in thousands, then we can just put 150 in our formula right there for our population. So I'm going to have 150 equals 108 e to the 0.013 t. First thing I'll do is divide by the 108 from both sides. I could see if that's a nice number or not. 150 divided by 108, and it's ugly, and so that's not good. So I'm going to leave it alone. And so I am going to then rewrite this over here so I have more room. I'm going to write the e, no, I'm just kidding. I'm going to write my 150 over 108 equals e to the 0.013 t. So my boss is the one without the exponent. So my boss is going to be 150 over 108. So it is going to stay exactly where it is at. The e is going to now move over and become the little base. So this will be a natural log. And then my exponent will drop down and become this big guy here. And so now I have the natural log of 150 over 108, it's understood to be base e, equals 0.013 t. Divide by 0.013. And this is what I need to put in my calculator right there. And so here I go. The natural log of 150 divided by 108 divided by 0.013. And I get 25.27 years. On that one. So number 2, the weekly cost for producing X thousand iHeart Math pencils is given by this cost function. To the nearest whole pencil, find the number of pencils produced if the total cost is that. So it gave us the cost, so I'm going to put it in my equation right there. So I will have 3,546 equals 3,172 plus 73 times the natural log of x plus 7. So my whole goal here is to solve for x. It's kind of like peeling an onion. We got to start taking away parts. So I'm going to subtract the 3,172 from both sides. And that will leave me with 374 equals 73 times the natural log of x plus 7. Still working to solve for x. I need to divide both sides by 73. So I'm going to move up here. So I have 374 over 73 equals the natural log of x plus 7. When there's a log or natural log in the problem, whatever it's the log of is the boss. So my boss is currently on the right side, and I don't like that. So I'm going to switch places, but that's just me being quirky. And so that's the boss right there, x plus 7. It's going to stay right where they're at. My base for the natural log, even though it's not showing, it's understood to be base e. It's going to move over to here, and then this guy is going to move up to my exponent, 374 over 73. I'm kind of crunched for space there, so I'm moving over here now. So I'm just rewriting this. X plus 7 equals e to the 374 over 73. Solving for x, I need to subtract 7 from both sides. So I get e to the 374 over 73 minus 7. And then that's what I'm going to put in my calculator right there. So here I go. I'm going to go to my, there's an E button over here, and there's also an E button over there. So e to the 374 divided by 73 minus 7. And I get 160.9, so I'm going to say 161, but it's in thousands here, so it's 161,000. So number 3 says find the domain. So when you're looking for the domain, there's 3 big things where the domain does not exist. You cannot have 0 in the denominator. We don't care about the numerator. But you can't have 0 in the denominator. You can't have a negative underneath an even-rooted radical. And you can't take the log of anything but positive stuff. So when we're looking at these, what I see on part A here, there's no radical, there's no log, but there is a denominator. And again, we don't care about the numerator. So I'm going to set that denominator equal to 0 and see what causes that to happen. So there's several ways you could do this. One way is factoring. If you are good at factoring, or you like to factor, or you just see how it factors, this could be your way. But if it's not your way, don't freak out. I'll show you another way. So I needed 2 things that multiply to give me 30, but add to give me 13. So I have x plus 3, x plus 10. And so I get x equals negative 3 and x equals negative 10 are not in the domain. So those 2 numbers are not in the domain. So what I have to do is take my interval, which is negative infinity to infinity, and I'm going to take out those 2 numbers. So I'm going to go from negative infinity to the smallest one, but not equal it. Start up right after that smallest one to the next number, but not equal it. And then from negative 3 to infinity. So this is my interval where my domain does exist. Okay, so let's pretend that factoring is your worst enemy. Okay, so you get this. You could also solve quadratics on your calculators. You know how. You should know how. I hope you know how, because you're going to have to do number 7 here in a little bit. So just graph this and find the x-intercepts. The x-intercepts are where the quadratic equals 0. So I'm going to go to y equals, and I'm going to graph x squared plus 13x plus 30. I'm just going to zoom 6, a standard window. I can't see both of them, so my x min needs to be a little smaller. So on my window, it's at negative 10. I'll just go to like negative 20. So I graphed just the denominator. I don't even care about the numerator. I just want to know, where does that denominator equal 0? So I graphed it, and wherever it crosses the x-axis is where it equals 0. And we can find that by going to second trace number 2. So second trace number 2. Say I want to find this one on the left first. I'm going to have to move my cursor to the left side of it. There we go. So my cursor's on the left side, and I'm going to hit enter. Then I'll move it to the right side, and I'll hit enter and guess. And at the bottom, it tells me negative 10. I'll find the other one, second trace, number 2. I'm already on the left side, so I can hit enter at any time. I'm just getting a little closer. Oops. Left side, enter. Move it to the right side, enter, and guess. And it says negative 3. So if you can't factor, you can graph it and find them this way. We just found they're negative 10, negative 3. Those are the 2 places this quadratic equals 0. So those are the 2 numbers I would take out of there. All right, so on part B, I'm just going to factor it real quick. And I get x minus 3, x minus 8. And so I get x equals 3 and x equals 8 are not in the domain. They're not in the domain. So taking them out of the interval, I would go from negative infinity to 3, and then from 3 to 8, and then from 8 to infinity. And again, if you can't factor that, graph it and find your x-intercepts that way. For part C, we have an even-rooted radical. So whatever's underneath has to be greater than or equal to 0. So 5 minus x is greater than or equal to 0. If I subtract 5 to the other side, I get negative x is greater than or equal to negative 5. Right here I'm going to divide by a negative, so my sign's going to flip the other direction. And I'll get x is less than or equal to 5. So writing this out, 5 is the largest it can be. So it can go from negative infinity all the way up to 5 and equal 5 on that one. All right, and then part D. We have the natural log of stuff. So x plus 15 has to be greater than 0. Subtracting 15, x has to be greater than negative 15. So it starts at negative 15 but does not equal it and goes all the way to infinity. Okay, I'm going to do number 4 with you. So it says it costs $1,842 to make 400 items. To make 640 items, it costs $2,160. What is the cost function? So it gives us 2 points. Price is always y. So I have the point 400, 1842, and I have the point 640, 2160. And basically I want to find the cost function, which is just the equation of a line, y equals mx plus b. I personally would use my calculator on this, so I'm going to do it that way first. So what I would do is go to my calculator and put my x values in list 1 and my y values in list 2. So I'm going to go to Stat, Edit, and in list 1 I put 400, 640, and in list 2 I put the corresponding y values. All right, so now I'm going to hit second quit. I'm going to go to Stat, Calculate, and choice number 4 is linear regression. So just hit enter until you see your equation. Y equals, or C of x equals if you want to. Why'd it go away? 1.325x. Plus 1312. Oops, that's not looking good. So that's what I would do. I'd use my calculator in my list and do it. Now, if you don't like that, you could do it by hand. You could say the slope is going to be y2 minus y1 over x2 minus x1, and do your y values, 2160 minus 1842 over 640 minus 400, and you would get 1.325. And then you would have y equals 1.325x plus b. To get your b, just pick either one of your points to plug in for x and y and solve for your b, and you get it by hand doing it that way. Okay, so number 5, it says give the minimum degree, tell if it's odd or even, positive or negative. So these ends are both pointing in the same direction, which makes this even. Since they're both pointing downward, it makes it negative. And then you count 1, 2, 3 turnarounds, so the minimum degree this could be is 4. On this one, the ends are going in opposite directions, so this makes it odd. Since the left end is going up, it makes it negative. And then you count 1, 2, 3, 4, 5, 6 turnarounds, so the minimum degree is 7. Okay. So number 6 says Mr. Hurst works at Best Buy where they're planning to release a new tablet to compete with the iPad. After doing some market research, they discovered supply equation for these tablets is represented by this, while the demand equation is represented by that. What is the equilibrium price? Well, if we set the demand equal to the supply and we find where they intersect, that's the equilibrium point. X naught is the equilibrium quantity, and P naught is the equilibrium price. So there's several ways you can do this. The way I personally would do it is I would graph these in my calculator and find the point of intersection. So I'd put one of them in y1 and one in y2. So that's what I'm going to do real quick. So I'm going to y equals. I'll put my demand equation in, negative 0.26x plus 601. And I'll put my supply equation in, 0.14x plus 321. I know zoom 6 will not work because my y-intercepts, which is where it crosses through the y-axis, I've got one at 321 and one at 601. So I'm going to go to my window. My y-max is 10. That's nowhere near 601. So I'm going to make it twice the size of 601, so about 1200, just so they go through the middle of my screen. And if that's 1200, this is going to be more than 10. I don't know what it's going to be, so I'm going to start off by just adding a 0. Now if I graph these and it looks like parallel lines, which it kind of does, that always means that your x max is not big enough. It's not big enough. So I'm going to go to my window and I'm going to add a 0 to my x max and graph, and there we go. So I'm going to go to second trace number 5, enter, 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 and I get the point 700, 419. 700 is the equilibrium quantity, 419 is the equilibrium price. So that's if you solve it on the calculator. Now I love solving on the calculator, but I've also had many, many years of practice of that. So that could drive you nuts trying to find that window. So alternatives could be two. I'll give you at least two alternatives. You could set these equations equal and solve by hand. I'll just put an X there. Equals this one. And so if you add that over, you get 0.4x, and if you subtract that over, you get something. What's 601 minus 321? 280. Divide by 0.4, divide by 0.4, and we get x equals 700, which is the equilibrium quantity. Then you can either put it back into either equation, and it'll find your equilibrium price for you. So that's another way you could do it. Number 7, find the largest x-intercept for this graph. So I'm going to graph it and see what it looks like. 2x squared minus 3x minus 8. So y equals 2x squared minus 3x minus 8. I'm going to try just to do zoom 6. Oh, that's not bad. So I have two x-intercepts. I've got one there and one there. And this one says to find the largest one. So it's not going to be the one that's negative. It'll be this one over here. So finding this largest x-intercept, I'm going to go to second trace. Number 2 is 0. Left side, I'm already on the left side, but I might just get it a tad closer. Hit enter. Right side, I need to cross over and go to the right side. And hit enter and guess. And at the bottom of the screen, it'll say 2.886 and then 0, 0, 0, 0, 0, 0. So my x-intercept is 2.886. Solve in exact form, no decimals. That means don't put these in your calculator. So this one has a base of 3, and this one has a base of 81. I'm going to turn them both into a base of 3. So 3 to the 6x minus 5. 81 is 3 to the 4th, and that's to the x. Power to a power, you multiply. So this will be 3 to the 4x. Since they both have a base of 3, then I can just set the exponents equal to each other. Subtract that one over, and I get 2x, and add that one over, I get 5. So I get x equals 5 halves. On this one, it has a logarithm already in it. I don't have to subtract anything or divide by anything in front of it. It's ready to go ahead and change forms. So this is the boss, going to stay right where it's at. The little base is going to move over and become the big guy. Bumps the 3 up. So I get x plus 9 equals 64, and subtract my 9, and I get x equals 55. And then part C, I need to divide the 6 out first. So I get e to the x plus 7 equals 12. The boss is the one without the exponent, so 12 is the boss. So even though this is not necessary, Dr. Pogue has to do this for some quirky reason. I don't know why. So the boss is on the left, stays there. E is going to move over, become the little power. If it's e, we got the natural log. X plus 7 comes down. Subtracting 7, I'm going to have the natural log of 12 minus 7 equals x. And I cannot combine those because the natural log of something cannot add or subtract with just a regular number. All right, number 9. Dr. Pogue has decided to produce and sell rings that say, I heart math. The price demand equation for the cost and the cost function are given respectively. So here's our price equation, and here's our cost equation. X is the number of rings that can be sold at a price of $p per ring, and C of X is the total cost in dollars of producing X rings. Determine the break-even points. Well, break-even points occur where the revenue equals the cost. The little problem with that is they didn't give us the revenue equation, so we're going to have to find that up here. So revenue equation equals the sell price times X. Our sell price is highlighted in yellow here. When I write this out, when I write my sell price out, I don't like having X over 30. I'm going to pull my number out front and make it negative 1 over 30 X plus 200 times X. And so my revenue is going to be negative 1 over 30 X squared plus 200 X. So it didn't ask me to find the revenue, but I needed to because I need to know where the revenue equals the cost. And while we could set those equal to each other and solve by hand, it's a quadratic and this is going to be very ugly. So I'm going to graph my revenue equation in my calculator, and I'm going to graph my cost function, and I'm going to find my break-even points, which are the points of intersection. So I'm going to put my revenue in Y1 and my cost in Y2. So Y equals, my revenue is negative 1 over 30 X squared plus 200X. And my cost equation, 72,000 plus 60X. And I can zoom 6, although I know it's going to be horrible, but it'll at least get me back to square 1. And now I'm going to change my window using the educated guessing that I've taught you. So the X-min and Y-min do not change. It's the X-max and Y-max that are going to change. So I'm going to go to my window. I'm going to go down to my Y-max. I'm going to look at these highlighted equations over here. My y-intercept was 200, and this y-intercept was 72,000. I'm going to take the larger one and multiply it by 5. It might not be perfect, but it'll give me a good guess of where to start. And then for my x-max, I have no idea where to start, so I just add a 0 and see what that does for me. And I'm going to hit graph. Boom. So I see them way at the bottom of my screen, which tells me my y-max is plenty fine, but my x-max needs to be a lot bigger because they almost look parallel. So I'm going to go to my window, and I'll start by just adding another 0. And it's getting better. It looks like I need to go a little more than double or triple that. So maybe 3,000. Not good enough yet. Maybe double that one. 6,000. And so let me just remind you right here, if finding the window is taking you way too long on test day, then do the x equals negative b over 2a. Find the vertex by hand. And then using that vertex you found by hand, make your x max twice that big, and that'll just help you set it from the get-go. All right, so I'm finding my break-even points, my points of intersection. I'm going to go to second trace, number 5, enter, enter, enter. So there's one of them, 3,600 and 288,000. That was the larger one over here. I need to find the smaller one, so I'm going to go to second trace, number 5. First curve enter, second curve enter, and I got to change my guess to the other one, enter. And that one's at 600 and 108,000. Those are my 2 break-even points. Then it says, what is the maximum revenue? In part C, how many rings are needed to maximize the revenue? So I'm going to find this maximum right here, x, y. The y value is the maximum revenue. Oops, that's right there. The x value is always how many units are needed to maximize the revenue. So in this case, how many rings are needed to maximize the revenue. So finding that maximum on my calculator, I'm going to go to second trace, number 4. Left bound, I'm already on the left side of it, so I'll hit enter. Right bound, I'm going to move to the right side and hit enter and guess. And at the bottom of my screen, I have 3,000, 300,000. So I'll write that down. So the maximum revenue, that's the y value, and that's money, so it's $300,000. And how many rings are needed to maximize the revenue? That's the x value, so 3,000 rings. Then it says, what should the rings be priced at in order to maximize the revenue? We saw the price equation right up here. It's in yellow. So I'm going to write my price equation right here. P equals negative x over 30 plus 200. So to find the price needed to maximize the revenue, I'm going to take the x value that we found will maximize the revenue. And I'm going to plug in x equals 3,000 here. So I get negative 3,000 over 30 plus 200. And I get that the rings need to be priced at $100 each to maximize the revenue. Okay, it says find the profit function. So the profit function is revenue minus cost. So I'm going to write out my revenue equation that we just found, negative 1 over 30 x squared plus 200x minus, here's the important part, parentheses around your cost. So distributing that negative sign, I'm going to have negative 1 over 30 x squared. 200x minus 60x is minus 140x, and then minus 72,000. That would be my profit function. It says how many rings are needed to maximize the profit? What is the maximum profit? So I need to graph this profit function. And when I graph it, it'll be just like a little mini-me on my graph right there. And I want to find the maximum. I could use the equation I just found, but there's such a big chance that you might have made a little mistake on that one that I would suggest, since you already have the revenue and cost in your calculator, to go to your y equals screen. Your revenue's in y1, your cost is in y2. So in y3, I would put y1 minus y2. So I'm going to go to vars, V-A-R-S, y-vars, function, y1, minus vars, y vars, function y2. That's my revenue minus cost. And I'll hit graph. It's down there at the bottom. I want to find the maximum. I'm going to go to second trace, number 4. If I'm on the wrong one, I need to hit down, down. I'm going to get on the left side, hit enter, move it to the right side, hit enter, and guess. I get 2,100 and 75,000. So it says how many rings are needed to maximize the profit. That's the x value. What is the maximum profit? That's the y value, $75,000. And then what should the rings be priced at? There's that price equation again. So I'm going to write the price equals negative x over 30 plus 200. What should they be priced at in order to maximize the profit? So I'm going to plug x equals 2,100 in this time. And I get that they need to be priced at $130 each. All right, number 10. Leroy started up a business where he makes origami roses and sells them during Valentine's week. The cost function for producing a rose is right there, where x is the number of roses produced and C of x is the cost in dollars. If he prices them at $3.50 each, how much profit will he make if he sells 150 roses? And so I know that my profit equation equals my revenue minus my cost. They gave us the cost equation. They gave us the sell price so we could figure out the revenue. So the revenue is going to be the sell price, which is $3.50 times x, however many they sell. And so I'll find my profit by putting in my revenue equation, 3.50x, minus parentheses, my cost equation. And so I get my profit to equal, if I distribute my negative here, 3.5x minus 0.28x equals 3.22x minus 1.35. That's my profit equation. And I want to know what the profit is when they sell 150 roses. So I'm going to plug 150 in for x right there. So then if I multiply 3.22 times 150 minus 1.35 on my calculator, I will get $481.65. Number 11. This is from 10.3. Actually, number 11 and 12 are both from 10.3. To find x-intercepts, that is where we set the numerator equal to 0. And so I'm going to set 3x squared plus 6x equal to 0. I can take a 3x out of both of those. Leaves me with an x plus 2. So I get either 3x equals 0, which means x equals 0, or x plus 2 equals 0, which means x equals negative 2. So I've got two x-intercepts here, one at 0 and one at negative 2. The y-intercept is where I plug x equals 0 in for everything. So on top I would have 3 times 0 squared plus 6 times 0 over 0 minus 4. So I have 0 over negative 4, which is just 0. And so I have a y-intercept at 0, 0 also. I could have written these as points over here if I wanted to, just so you know. Horizontal asymptote, that's where we do the whole Bobo Botten eats RC thing. So it's bigger on bottom 0, bigger on top none. Exponents are the same, you reduce the coefficients in front. So our highest exponent on top is 2 and the highest one on bottom is 1. So it's bigger on top none. vertical asymptote, that's where we set the denominator equal to 0. So I set the denominator equal to 0, and I get x equals 4. All right, number 12. Sketch 3 possible graphs for each of the following. So for part A, things we know. We know it's an odd exponent, so this is an odd function. So the ends are going in opposite directions. The coefficient is positive. So not only are they going in opposite directions, but the right end is up and the left end is down. And since the degree is 7, we have at most 6 turnarounds. So drawing 3 possible sketches for part A, I need to go in opposite directions with the right end up and at most 6 turnarounds. So I could have 1 turnaround, 2, 3, 4, 5, 6. So it could look like that. Or I might just have 4 turnarounds. 1, 2, 3, 4. Or I could have 2 turnarounds. And I'll just throw in a bonus example. It might not be any. So all 4 of those could represent the graph of 4x to the 7th. We just know it's odd, positive, and at most 6 turnarounds. Whereas this one has an even exponent. So that means ends are going in the same direction. Negative in front means the ends are both pointing downward. And 6 for our degree means at most 5 turnarounds. So sketching these graphs, I could have 5 turnarounds. 1, 2, 3, 4, 5. Maybe I just have 3 turnarounds. Maybe I just have 1 turnaround. 3 possible sketches.